You ask the model for a structured answer, and you got one. It parses, it matches your schema. Every field is the type you asked for. It's also wrong. And notice what it never said. It never said it wasn't sure. A schema guarantees your output will parse. That's the only thing it guarantees. To see why, we have to go down a level to a single decode step. This is one step of generation. The model doesn't pick a word yet. First, it scores every word it knows. One number for every token in the vocabulary. 200,019 of them for GPT-4o's tokenizer. That's the logit vector, just scores. Those scores became probabilities, and one token gets picked. Then here's the part that matters later. That token gets added to the input. So the next step sees it. And the step after that. Everything the model writes becomes context for whatever it writes next. Now watch what a schema does to this. Your schema gets compiled into a state machine. At any moment, the machine knows which tokens are still legal. If you've written an open brace and a quote, the next token has to continue a valid key. Nothing else is allowed. So every illegal token gets its score set to negative infinity. And that happens before the scores become probabilities. So an illegal token's probability is exactly 0. The survivors get rescaled and the model picks from what's left. A schema doesn't ask the model for JSON. It deletes every token that would break the JSON. Every step. I ran this myself. Real tokenizer, real schema. Here's the first decode step. Before the model has produced a single character, 2 tokens are legal. 2 out of 200,019. An open brace, or an open brace with a quote. 99.999% of the vocabulary is already dead. Look at that and you'll draw the obvious conclusion. Of course it got worse. You just destroyed its options. That conclusion is wrong because somebody measured it. A group at UC San Diego separated the two things everyone confuses: asking a model for JSON and actually masking the tokens. On average, asking for JSON costs about 4 points of accuracy. Turning the mask on costs about 1.5 more. 1.5 points. That's the whole cost of the thing everyone blames. And that average hides something worth saying. Every open weight model they tested paid the tax. 3 of the 4 closed models didn't. No real drop or a small gain. 4 models, 3 providers. The authors say straight out that's too few to generalize. The tax is real, but it's paid at the prompt, not at the decoder. So what actually broke it? Go back to how generation works. The model writes left to right, 1 token at a time, and every token it writes becomes context for the next one. So the first thing it writes comes out with nothing in front of it. It hasn't worked anything out yet. Now look at your schema. If your answer field comes before your reasoning field, the answer gets generated first. The reasoning comes after the answer. So it's a justification for a verdict the model already reached. The model didn't get dumber, it answered before you let it think. This is in the paper everyone quotes. When they looked at GPT 3.5 in JSON mode, 100% of its answers put the answer key before the reason key. Every single one. The model had to commit before it was allowed to work. Then a different experiment isolated it. Dylan Castillo ran GPT-4o on 50 reasoning questions. Same questions, same prompt, same model. The only change was the order of the 2 fields in a class definition. Reasoning first, then answer, 46.7%. Answer first, then reasoning, 33.3. 13 points for moving 1 line, and nothing was masked differently. The only thing that changed was the order. Your schema is deciding the order the model thinks in. Now, the mask does one thing that's genuinely its fault. Go back to that verdict field. It's an enum, guilty or not guilty. Here's what's legal after the model opens that string. I ran it. 6 tokens, G, GU, GUI, N, NO, NOT. That's everything it's allowed to say. I don't know isn't in there. Insufficient evidence isn't in there. Those tokens are set to negative infinity. Same as anything else that breaks the schema. Your enum didn't just constrain the answer. It deleted the option to not have one. So the model didn't lie to you. Every honest thing it could have said was already gone, which tells you how to fix it. And the fixes match the crimes. The reasoning drop came from field order, so move the field. Put reasoning before answer in your schema. That's the one-line version, and it's worth 13 points. If you can afford a bigger change, let the model reason in plain language first, and only then put the schema around the final object. The same paper that found the problem measured that fix. Performance comes back close to where it started. The deleted abstention came from the mask, so give it back. Make the field nullable. Add an unknown case. If I don't know isn't in the grammar, the model can't say it. And check the meaning yourself. The grammar checks that your JSON parses. It has no opinion about whether it's true. One more thing, because leaving it out would be dishonest. Sometimes the constraint makes the model better. On some classification tasks, plain JSON mode beat free text. A schema can shrink a noisy answer space. On parsing tasks, a grammar stops the model producing garbage in the first place. It depends on whether the constraint is fighting the task or helping it. So use structured output. It's a good tool. Just know what it's actually doing. Your schema is scheduling your model's thinking.